In this video, we are going to look at different sequences and figure out if they converge or diverge. Now, it is very important on a test to understand the difference between convergence and divergence of a sequence and convergence and divergence of a series. And unfortunately, a lot of students mix them up. Okay, so when you look at the formula sheet, and I included, and I have all these tests like PP series, divergence tests, all of these other tests. These are all for series, not for sequences. The sequences, we only have a couple over here on the top. That's all we need. All right. Everything else is just have to know how to take limits. Okay. But you do not use any kind of test for sequences. That's the problem that I see a lot. People will say, oh, this P series. Excuse me. This is not a series. This is a sequence. So sequences, how do we know when they converge or diverge? We have to take the limit as n approaches infinity. And if that limit is a number, then it converges. And if the limit is a not a number, basically, then it diverges. Okay, so let's look at the first one. Okay, so this sequence a sub n is 4 to the power n plus 1 divided by 7 to the power n. Now, I can actually use properties of exponents to break this thing apart on the top, because I can just say that that's the same as 4 to the power n multiplied by 4 to the power 1, right? And then I'm dividing that by 7 to the power n. And what I can do at this point is just move the 4 to the front, and then I can see that this is 4 divided by 7, and everything is raised to the power n. Now, what do I know about sequences like that? So if I open my formula sheet, this sequence is R sub n. So I don't know if you could see it. It's kind of small. Yeah, it's increased in the browser, but not the formula sheet. Okay, so anyway, this R sub n sequence, where R is a number, we know that it converges to 0 if absolute value of R is less than 1. Okay, so this R sub n will go to 0 if absolute value of R less than 1. Now, if R is positive and it's more than 1, then it's going to go to infinity if R is positive. Okay, now if R is equal to 1, then that's just 1, so it'll approach 1. But if R is negative and less than negative 1, so if R sub n, if R is less than negative 1, then it is going to just diverge. So this is the limit is not going to exist, because like some of the terms, because this is going to alternate signs, and some of the terms will go approach positive infinity, like the even ones, and odd terms will go to negative infinity. So overall, that thing is not going to exist. Now, what case do we have? Well, for us, we have that 4 over 7, and 4 over 7 is less than 1. When you take absolute value, that's just also going to be 4 over 7 because it's a positive number. And that means that the sequence is going to go to 0. Now, if I were to ever, like, not sure, okay, I'm just like, well, I'm on a test, I'm worried, maybe it's 0, maybe it's infinity. Okay, well, it's nothing can be easier than if you have the Desmos calculator in your hands. So let's open that and let's just type a sub n equals 4 to the power, just put the original one. You don't know anything. You just type in the original one, okay? You didn't know what to do, what happens to these R to the n sequences. Okay, just plug in. What is A of 10? What is A of 100? What is A of that? Well, calculate gave up, okay? But even at 100, look at that number, 10 to the negative 24. What does that mean? It means that you have to move the decimal point 24 to the left. So it's like 23 zeros, right? And a 1987. So it's a sequence that's so fast. It goes to 0 so fast. So I know this thing is going to go to 0 and it is going to converge. Now, what would have happened if you had them reversed? If you had 7 on the top and 4 on the bottom, what would have happened then? Well, it would diverge to and it would go to positive infinity. So let's look at that. So let's start with 1. Let's go to 10. Then go to 100. Oh, now look, it's 10 to the 25th power. So you already get, well, calculator just gives up, but the 1,000 is just the number is too big. It cannot even do it. But you can see that the numbers would go to positive infinity if they were reversed. Okay. The next part is the sequences that have polynomials, possibly also taking a square root out of them or some kind of cube root, fourth root, whatever. What happens with those? Well, those sequences, you need to know that the behavior of a sequence is completely determined by the highest power term when you have polynomials and or square roots of polynomials. In other words, when you see a polynomial like this, like I have on the top, and I want to know what happens at infinity, the only term that matters is this one right here. Everything else can be discarded, okay? So the limit of my sequence Bn, limit as n approaches infinity of Bn, is equal to the limit. So on the top, I'm only keeping the highest power term, which is 2n cubed. It is square rooted, so I do have to put the square root, okay? And then on the bottom, I'm going to have that 3n squared. And all the other terms make no difference. It's like a million compared to a dollar. That dollar is not going to make a difference. Okay, so what do I do next? Well, I need to know properties of exponents. So first of all, let me split the square root. So this is going to be square root of 2 multiplied by square root of n cubed. But what is that? So how do we simplify something like this? How do we write it as just one power? So when you have something like this, the rule says that you first start with the m, that's in there, and then you divide it by the index of the root. So what is the index of the root? This number right here. That goes in the denominator. So what is square root of n cubed? How can I write it as n to some power? So I'm going to start with that m, which is 3 for me, 3, divided by the index of the root. Now, square root, we usually do not write the index, but the index of the root is actually 2. So this is going to be 3/2. So this is like default index if it's not there. But if it was something like 3 or 4, then you would be dividing by that number, right? And here you're dividing by 2. Okay, on the bottom I have 3n squared. Now, what happens here? That's going to completely be determined by which n has a higher power. If n has a higher power on the top, then the whole thing is going to go to infinity. If it's on the bottom, then the whole thing is going to go to 0. But your teacher will probably want you to show that. Well, the way you do that is, again, you use properties of exponents, and when they're divided, you are subtracting them, and you put the larger one was on the bottom, and that's where it's going to be, the difference, okay? So it's going to be on the bottom. So you're going to have square root of 2, you have 3, and then n is going to be to the power 2 minus 3/2, which is 1/2. So you can see that you have a infinity on the bottom, because square root of infinity is infinity, and when it's on the bottom, it's like some number which is square root of 2 divided by infinity, and that's 0. Again, if you're not sure, let's say you're like, oh, I don't know, is it that or not? Okay, so take the square root of 2, divide by 3 square roots of n. Check out what happens at 10, at 100, and 1,000, 10,000, so on. Now, it's not going to 0 as fast, but it definitely is going to 0. So you can tell that that thing is going to go to 0. So this is going to go to 0, and that means the sequence is going to converge. Again, sequence converges when the answer is a number. It's not a number, it diverges. Okay, so this one is actually super easy. I'm going to do it in my head. I can just cancel all the other terms. So this is just going to be negative 9n squared. And on the bottom, I got negative 4n squared. And n squared and n squared are going to cancel. And then you're just going to wind up with negative 9 over negative 4, which is 9/4. Now, that is a number. So that means it's going to converge.